Okay, hello everyone. So in this video we're gonna learn how to integrate trigonometric functions that contains tangent and secant functions or mix of them. Okay, all right. Now before we do that, we have to recall some of the identities and some of the results. Okay, so one identity we need is the tangent and secant version of the Pythagorean identity. So 1 plus tangent square is equal to secant square. That's the Pythagorean identity written in another way. And the other thing you want is derivative of tangent is secant square, derivative of secant is secant times tangent. So we need these three facts, so hopefully you can remember them. Alright, now to understand the strategy to integrate a function like tangent times secant, we have to back it up and go back to our previous video. How do we integrate if you have sine square x and cosine cube x? What is the approach? When you have an odd power, what we did is we split the odd power, right? Cosine square x, cosine x. And then we did integration by substitution. But our choice for you is the opposite function for what you split, right? So we split cosine, then your u is sine. Now why is that? What is the reason behind this choice, behind this rule of thumb? The reason is derivative of your substitute is cosine, right? The function that you split. Then you can cancel out the part that you split if you choose your u very smartly, right? So here if you split sine, then your u will be cosine because derivative of cosine is sine again. Then you cancel out that part when you replace dx, right? Because du over dx here is cosine and dx is du over cosine, right? Now when you replace dx by this term here, you will cancel out the part that you split out. That is why we had this kind of a smart choice for you, right? A rule of thumb for you. Alright, now we use the same idea when we have tangent and secant problems. So let me show you a one. So let's say you want to integrate tangent square x and secant 4x. Okay, alright, so this is a one category. Okay, so in these tangent secant problems also you have two categories, when secant power is even and when the power of tangent is odd. So there are two categories, but in this video I'm only talking about the category where power of secant is even. Okay, all right, so now we have to integrate this, and let's recall the fact derivative of tangent is what? Secant square. Now here's my question for you. Try to pause this video and try to figure out this. Okay, try to pause this video and think, what is the function that you're gonna split and what is your u? Think about it. Pause the video and think. Okay, so hopefully you paused the video and thought about that. Well, now we know derivative of tangent is secant square. So what if I will choose my u to be tangent? Okay, then what should I split from here? Well, I can split a secant square, right? See what happens. Tangent square x, now I'm gonna split out a secant square. I'm not just secant square. So that's a one difference from sine and cosine problems. Okay, I'm gonna split out two powers, power of 2 of secant. Okay, secant square. Now you know why is that, because derivative of tangent is secant square. We can cancel out that secant square, right? Let's see, du over dx, derivative of tangent is secant square. Now then dx is du over secant square, right? If you switch the sides here, so you get this. Now let's do the integration by substitution. So we have tangent square, which is u square. Secant square, we have a one extra secant square. Let him be like that, it's okay. This secant, okay, we have a secant square is also here. Dx is du over secant square. See, we got that cancellation just like in sine and cosine, but in these type of problems you cancel out a secant square actually. Alright, so you can see we are left with u square secant square x du. But the problem is still there because we have an extra secant square left. What can we do about those excess terms? How did we deal with those excess terms? We use Pythagorean identity, right? That is exactly what we did in sine and cosine problems. We choose our u smartly, and you cancel out terms like here, right? You will cancel out this term, but excess terms, you get rid of that excess terms, or you write those excess terms in terms of u using the Pythagorean identity. What is the Pythagorean identity here? 1 plus tangent square x is secant square x. So the secant square is actually 1 plus tangent square. What is tangent? U. So this is u square times 1 plus u square. Right? Okay, let me finish the integration and come back to this problem again. So you can distribute this u square. So this is u square plus u to the 4 du. And if you integrate u square and u to the 4, this is u cube over 3 plus u to the 5 over 5 plus c. U is tangent. So tangent cube x over 3 plus tangent to the power 5 x over 5. This is the answer, right? Okay, I did that fast because this step is easy. Let's back it up and let's summarize this. Okay, what's going on here? All right, so here's my summary. When you have an even power for secant, what you do is split out secant square. Always split out secant square. When you split out secant square, choose your derivative to be, choose your u to be, substitute to be tangent, because derivative of tangent is secant square. So you can cancel out that secant square that you split out. Okay, so likewise you can cancel out this secant square, and then rest you have function of u because your tangent is u, and then the excess terms you can get rid of Pythagorean identity. Now understand, you can do that. All right, you can split out secant square only if you have an even power here. That's the part I want you to understand. Another part that I want you to understand. Okay, think about if you have, okay, I will show you two scenarios. Think about if you have a secant cube here. Can you do that? Let's see. Let's split out secant square. So if you split out secant square, you will left with a 1 secant here, right? So you have secant square x. Now because you split out secant square, your u will be tangent x, so this will be u square, right? I will save time by skipping steps. This secant square will be vanished because the similar process, okay? And then you will have a du. Now can you get rid of secant x here? Well, it will be difficult because 1 plus tangent square is actually secant square, not secant. Okay, so this will be like, so if you want to get secant, you have to take the square root of Pythagorean identity here on the left hand side, right? And that will be square root of 1 plus u square. And if you have square root of 1 plus u square, that's not very easy to integrate. Okay, that's another trouble. So that is why when you have an odd power here, it really doesn't work out. How about if you have to the power 6, higher even power? Well, if you split out a square, this will be power 4, right? This will be power 4. Now how can you get secant to the power 4? Well, we know secant square is 1 plus tangent square, so secant to the power 4 is square of this, so this is square of this, so this is actually 1 plus u square square. Now u square times 1 plus u square square, that's easy to handle, right? U square times 1 plus u square square, you can FOIL this out and do the integration. That's easy. So when you have even power for secant, split out a secant square and choose your u to be tangent. Excess secant powers, excess secant terms will be removed using Pythagorean identity. Okay, hopefully you understand this. Okay, try to pause the video, try to do these problems again, try to spend time on thinking why we use different rules, like why we have even, think again why we have secant, or why we only deal with secant to the even powers, okay, in this process, and why do we split secant square, what is the reason for choice of u to be tangent x, okay, and why we get rid of excess secant terms using Pythagorean identity. Think about them, spend time in thinking about them, and then you will master these topics. Okay, alright, so that's it for this video. In the next video we are gonna learn how to solve problems when you have odd power for tangent. Okay, alright, so I will catch you there. Thank you very much. Bye bye.